Voltage. A neuron transmits nerve impulses through the axon into its axon terminal in voltage, which is illustrated in millivolts.
Sodium-potassium pump. In the sodium-potassium pump, 3 sodium compensates for 2 potassium. So in summary, the sodium-potassium pump is the process in which 3 sodium ions exchange for 2 potassium in the active transport. Sodium is normally in the inside and potassium is usually located on the outside of the axon during active transport.
Action potential. Resting potential is outlined at the bottom of the graph at negative 70 millivolts. The threshold, which is at negative 55 millivolts, outline the all or none phenomenon, in which a response is triggered if the stimulus surpasses negative 55 millivolts. Depolarization, indicated by the red line, is the shift from resting to the peak of positive 35 millivolts. Repolarization, indicated by the blue line, is the shift from the peak back down to its resting point. Hyperpolarization is the line that surpasses the resting potential and back into its resting state.
The act when sodium gates open, in which sodium flows inside the axon through the sodium channel, is called depolarization. Hyperpolarization is when potassium flows out of the axon through the potassium channel, making the action potential slightly more negative until it recovers back into its resting state.
Action potential with non-myelonated axon. After a stimulus has occurred, there is a time frame, also known as the refractory period, in which the gates are unable to open. When the refractory period is over, that's when the sodium-potassium pump returns to its normal state.
Myelonated axon. In myelonated, the channel is located in the nodes of Ranvier. It travels faster than non-myelonated as it jumps from each node to node, known as a saltatory conduction.